So in this video I want to talk about cubics, quartics, and greater polynomials as well. So just need to talk about that really quickly. So far you've looked at quadratics. Now a quadratic is a polynomial. It's a polynomial with an order 2. It means it's a polynomial where x is raised to the power of 2. We're going to look at cubics. That's a polynomial where x is raised to the power of 3. We're going to look at quartics. That's a polynomial where x is raised to the power of 4. But we can also do pretty much all of them because as we go up to polynomials with degree 5 or 6 or 7, 8, 9, 10, a million, they all follow the same patterns. So we'll do all of them in one big shot. So here, what I'm looking at the moment is a quadratic written in turning point form. You can see my a value here, my h value, my k value, and it's raised to the power of 2. If I move my a value, it'll squash up, but you guys know it's stretching up really. It'll flip, you know, and that works. H will move it left and right, you can see that, and k will move it up and down. So I'll just set it up here so that it's somewhere. Let's put it there. Let's put it here. Okay, so, and maybe just stretch it out a little bit. So there's my quadratic, but the question is, what if I change it into a cubic? What if instead of raising it to the power of 2, I raise it to the power of 3? What will change? Okay, this is a cubic. This is a cubic. Now, a standard cubic will start from on the left-hand side, on the bottom, and it will move up and up and up and up until it gets to here, which is called an inflection point. An inflection point, you can see my words here, and then it continues up and up and up and up and up. Now, all of the rules, thankfully, still apply. If I move my h value, my inflection point will move. If I move the k value, the inflection point will move up and down. You can see that. So I can transform a cubic the same way that I can transform a quadratic. Now a cubic will have an x, it'll have an x-intercept or a root or a 0. It'll also have a y-intercept. You can see there's a y-intercept. It's coming, it's there somewhere, down here somewhere. Okay, so that's a cubic. That's what a cubic looks like. Of course, the a value is stretching it up, but I know it looks like it's squashing it. You guys know. You guys have that. I think you're good for that. Of course, if I change the a value to negative, it's going to flip upside down, and it's going to start from the top and work its way down. So there's our negative a value, flipping our cubic. And then it looks like it's compressing it as that number gets greater, but we know it's squashing it out. All right, that's it. That's a good understanding of cubics, I hope. You can see it's written in the same form as a quadratic in turning point form. We just have it raised to the power of 3 here. Has a nice little inflection point, and whenever it's written in turning point form, it'll have an inflection point. We will see cubics later on that don't have inflection points. What about quartics? What if I raised to the power of 4? Let's see what happens to this if I raise to the power of 4. Alright, so you can see I'm raising it to the power of 4. What we get is what looks like a quadratic with a sort of squashed bottom, a squashed turning point. So same rules apply. Even though it's a squashed turning point, there is still a singular turning point. You can see it'll appear here somewhere. There is still a singular turning point. It's just that it gets very, very close to the turning point, and then it comes back up again. And all of the rules still apply. So anything you know about quadratics, you can apply to quartics. They're the same shape, except with that little squash bump. All of the k values do what they're supposed to do, all of the h values do what they're supposed to do, all of the a values do what you already know that they're supposed to do. Now, that's cubics, that's quartics. Polynomials greater than that follow a similar pattern. So here's 2, here's 3, here's 4, here's 5, here's 6, 7, 8, 9, 10. So you can see what's happening as the polynomials get larger in size. Our inflection point or our turning point gets sort of fatter. But as they are odd powers, so raised to the power of 7, you get this inflection point, and an even powers, you get this turning point here. Okay, so there's our little discussion on cubics, quartics in turning point form. You should also be able to, if you are shown a graph, you should be able to write what it is, as long as they tell you what the power is. Same way that you know about quadratics. All right, make sure you take some notes, make sure you've drawn some pictures based upon this video, and you should have a good understanding of cubics, quartics, and how they can be written in this turning point form the same way that quadratics were.